Today we are talking about the transformation of reflections. So we are going to identify and use reflections. If you're interested, this corresponds to section 5.7 in your textbook. It's of interest to you. All right. Some terms. A reflection is a transformation that creates a mirror image. The original figure is reflected in a line that is called the line of reflection. Another name for reflection is flip. So if you glance down on your notes, you'll see that there's always a line drawn between your original figure and your image. That line of reflection is what we are flipping our image over. Anyone need more time on this slide? Okay. All right, in that box, the reflected image is congruent to the original figure. So off to the side, they show you these dark triangles are the figures, the original and the image. The orientation of the reflected image is reversed. Okay, so here it looks like this pointy thing is pointing kind of towards the right side. And then when they reflect it, now that point is pointing towards the right side. So the orientation is reversed. The line of reflection is the perpendicular bisector of the segments joining the corresponding parts. Now, that is not super important that you have that statement memorized. It's more of just a fun fact. But if we were to join these top points that got reflected, so we're looking just at this original top point to the image top point. And they connected those 2 points together. The line of reflection is perpendicular to that connecting piece, and it splits that connecting piece into 2 congruent parts. Again, not something we're really going to use, more of a fun fact. Questions, concerns, need more time on the properties of reflections? Okay. Then we will do our best to reflect these. It's really fuzzy on the screen, but we should still be able to reflect these across these lines. It's a little bit clearer in your notes. So if I'm reflecting this letter E across this line of reflection that they gave me here, I'm going to just put a red line and use that as my line of reflection since their line's a little blurry. Okay, if I'm reflecting it over that line, which way is my E going to be facing? Okay, towards the other side, right? It's going to flip over. Imagine that like this was a really dark ink of some sort, like a stamp, and you flip a piece of paper in half and fold it over and smush it down and it leaves an imprint on the other side. That's what this is like. So we're going to have an E. Now again, just do this to the best of your ability. We're going to have an E that flips the other way. Really, it should be about as bold as that one is. But our E is facing the other way now. Questions about how that works? If you were to fold this along the line of reflection, those should match up with each other perfectly. Same thing for the next one if you haven't already tried it. Again, if we reflect this over this line of reflection now, it's actually going to look the same as the way we just drew it. Now it's just on the other side of that line. Okay, it should be a little bold. Notice though, I'm not changing its shape. It still looks like an E, it's just backwards. I'm not turning it other than just flipping it over. So it's not going sideways on me or anything like that. Questions? Jakeem? What about the third one? So which way is it going? Yep, it's flipping down. So this time it's actually still going to look like a letter E. It's not perfect, but it's close. Okay, got a little too much there. Okay, it should still look like a letter E, but the points that were closest to your line of reflection would still be closest to the line of reflection. So like those points, the red points I just made should match up. Or if I were to put a point up here, that's going to flip all the way down to here. Questions about lines of reflection? How to reflect? Okay, when we're just freehanding it, we're just kind of making it look similar. We'll get to a coordinate plane very soon. Questions about these ones before we move on? Okay. All right, this image isn't the best, but we'll work with it. Tell whether the figures are a reflection. So first, are the figures congruent? Yes, they appear to be the same size, the same shape. They are congruent figures, so that's important. Are the orientations reversed? Yeah, it was pointing up, this top point, and now it's pointing down. So I would say yes, the orientations are reversed. Are the lines connecting the corresponding points perpendicular to line M? Yeah, if we look at like the far left corners, if we were to connect those points, it would be perpendicular to line M. Same thing if we took the high and low points, still perpendicular. So yes, I would say that these are reflections of each other. I hear a lot of flipping, so I assume we're ready to keep going. CMT, you with us? Okay. Which segment is the reflection of segment AB in the x-axis? Which way does our x-axis go? Left to right. So our x-axis, so that's what we're focusing on, is here. So that's what they're using as their line of reflection for letter A. So our original figure is segment AB, which would be a reflection in the x-axis. JK would be the reflection in the x-axis. And which point would correspond to point A? J, the one that's closer to the line of reflection. A would turn into point J if we reflect it in the x-axis. Okay, now we're going to switch it up. Instead of using the x-axis, now we want to use the y-axis. So now which one is the reflection? ED, and which point corresponds to point A? Good, point D. This time we were the one further away from our line of reflection. Questions, concerns? Warm, fuzzy feelings? None of those? Okay. Well, we'll work on it. Wow, these printed super fuzzy on the screen. All right. Much easier to see on your notes paper, so that's where I would be focusing. Tell whether the gray figure is a reflection of the black figure. Now, these might not look gray. They might just look like clear or white and black. If it is a reflection, tell the line of reflection. Okay. You all right? Okay. So we're just asking, do we see a reflection here? If so, what's the line of reflection? So on this first one, the one on the far left, does that look like a reflection?
Yes.
Yes, and what would the line of reflection be? The x-axis. So we can see they're reflected about the x-axis down the middle, side to side. All right, on number 2, does that appear to be a reflection? No. What didn't change? It's a slide. That's what we were looking at yesterday. So if this was a reflection, then this top pointy part should have flipped down, or whichever way, or if it was started down, should flip up. So this one is no. The orientation didn't reverse on that one. If the answer is no, you don't identify a line of reflection. It's not a reflection. There is no line of reflection. What about the last one? Yes, I agree that is a reflection. What is our line of reflection? The y-axis. Good. We feeling comfortable about identifying reflections?
Wait, how do you know if it's the x or the y-axis?
Think about which line you would have to fold it on for them to match up against each other. So for this first one, number 1 on the left, we would have to fold our piece of paper along the x-axis if these are going to match up with each other.
Oh.
On this one, the last one, we'd have to fold it up and down along the y-axis for them to match up. Good question. Other questions? Okay, so now that we're good about identifying them, we are going to actually perform the reflection. So we are going to move the points. It's important to know what axis you're reflecting in, because that'll change how the problem goes. So on letter A on this slide, we're reflecting in the x-axis. I'm just going to highlight it in red so we know that's our line of reflection. Which point do you want to start with? Okay. If we start with W, W starts out above the x-axis. So when we reflect it, where do you think it'll end up? Below the x-axis. If it starts out 1 above, when we reflect it, how many below do you think it'll be? 1 below. So that point is going to be my W prime. What point do you want to do next?
Y.
Sure. Y starts out below the x-axis, so when we reflect it, it should end up above it. It was 1 below, so we're going to go 1 above. There's my Y prime. And last but not least, we have point D. Where do you think that's going to land?
Above
3 above the x-axis. Good. It was 1, 2, 3 below. So we're going to go 3 above. 1, 2, 3 above. That'll get me my D prime. Then we just have to connect our points to form our triangle again. Let me switch colors. And these are going to overlap each other. If you have one that starts out above, like some points above and some points below, then your figures will overlap. But still, if we were to fold it along this x-axis, they would match up with each other. Questions, concerns? Okay. What's a little bit different about letter B?
It's on the...
Good. We've got a couple of our points that are on the axis. Where do you think they go? On the axis. They're not moving. So if we were to fold it here, these points would just stay put. Okay, they were 0 away from the x-axis, so when we reflect it, they stay 0 away from the x-axis. Does that make sense? Okay, if it's on the line of reflection, it's not going to move. So this point is also going to be my A prime. This point is also going to be my T prime. Now Y and Z are going to be a lot more like what we just did in problem A. So where is Y prime going to end up?
Above.
How many above? 3. Notice that I keep my primes in line with the original point, meaning that if I'm just flipping it up, I'm not moving it around. It's just going straight up from where it was. It's my Y prime. And what about Z prime? 3 above. 1, 2, 3. There's my Z prime, and again, we can connect it to complete our shape. Kind of drew through my letters, but that's fine. When we're done with these, we should be able to see that if we were to fold along our line of reflection, that they match up with each other or would sandwich up on top of each other. Okay, if I had accidentally put my Y point further out, like if I had moved it out here on accident, hopefully we would be able to see that that's not going to work out because that wouldn't sandwich up. Questions, concerns? Okay, we'll keep moving. These ones we are reflecting in the Y-axis. If you haven't already done so, I'll give you a couple minutes to try them on your own. This time, though, if we are working in the Y-axis, we're not thinking about above versus below. We're thinking about what instead? Left and right. Good. Okay, same rule applies, though. If you have a point that is on the line of reflection, it's going to stay there. Where did H prime end up? You could give me coordinates, or you could tell me relative to the line of reflection. Okay, so we would end up to the left of our line of reflection. What about L prime? Okay, we would keep it in line with L, but move it 1 to the right of our line of reflection. G prime?
Left.
Okay, we'd go in line with G, but we would go left 4 for G prime. And what about U prime?
Left.
2 to the left. Keep it in line with U. How are we feeling about performing these reflections? So far, so good? All right, what's the easiest point on letter B? Z. Z prime stays right on top of Z. Ooh, wrong pen. There we go. Z prime. What about A prime?
Right.
1 to the right of my line. And M prime?
Right. And 3.
Good. 3 to the right. And U prime.
Right.
Okay, again, right 3, keeping it in line with U. Connect them, and we can see that we've got a reflection. Questions, concerns, warm, fuzzy feelings, cold pricklies. Okay, let's talk about writing a rule for these. So we could just start off by saying reflected in the blank axis. So on letter A, we're reflected in the x-axis. So that's useful. Reflected in x-axis. But I want to real quick take a look at our points. So let's look at the coordinates, for example, of point J. Where is point J? If I wanted an x comma y ordered pair for point J. 0, negative 1. 0, negative. What about J prime? 0, 1. Okay, let's now look at K. Is that a K? Mine's super blurry. Nope, that's an H. All right, let's look at H down at the bottom. Negative 3. Negative 5. Okay, what about H prime? Careful.
Oh,
Negative 3, 5 is my H prime. Okay, lastly, let's look at Q. Is that a Q? Okay, Q is at what?
Negative 4, 4.
Careful. Negative 4, negative 4, and Q prime is at negative 4, 4. Do we notice anything about these ordered pairs if we compare an original point to its reflected point? What's the opposite?
They're the same numbers, but the positive and negative are changed.
So we're on the right track. Lexi said something that's important, though. Do both numbers become its opposite?
The y-axis.
The y coordinate becomes its opposite. What about the x coordinate?
Stays the same.
It stays the same. So a general rule that will apply to anything reflected in the x-axis is that if you start off with some point A comma B, and I don't care if A is positive or negative, if B is positive or B is negative, if you reflect in the x-axis, your x coordinate does not change. It stays the same. Your y coordinate flips its sign. So it's the opposite. If it started positive, if it becomes negative. If it started negative, it becomes positive. So that is a general rule that always works for reflecting in the x-axis. X will stay the same, y will change its sign. If you want to write it out in words, you could do that too. X, same, y, change sign. Okay, questions about letter A? Okay, on letter B, what is our line of reflection? The y-axis. So this time we're reflected in the y-axis. We don't necessarily have to go through all the points, but let's just go through a couple of them. Let's see if I can make out any of these letters. P, let's start with point P. What are the coordinates of P? Negative 5, negative 1. And what about P prime? 5, negative 1. Okay. Let's also do point M. Is that the one down at the bottom?
Yes.
Okay. What are the coordinates of point M? They should both be negative, right? Okay. And what about M prime? Okay, we could do the rest of the points, but we should be able to see the pattern here. This time, which coordinate is staying the same? And which one's changing sign? X. So this one, it's like the opposite rule. So if you start with a point AB, it's going to become negative A, or opposite of A comma B. So if you reflect in the y-axis, y is the same this time, and the x is the one that changes sign. Questions, concerns about those rules? Warm, fuzzy feelings? Okay, so like I said yesterday, these ones aren't quite as straightforward as you're given a specific rule every time and you just have to apply it. These ones, there are general rules that we can apply to any problem. So for example, on these ones we are asked to find the new coordinates. Now, you could do this by graphing it and then finding all the new coordinates. Or you could just find the coordinates of your original figure and then use the rules we just talked about. So, letter A, what are these points? Is it A, G, and T? A, G, and I. Okay. What are the coordinates of A? 4, -1. What about G? 4, -5. And I? 1, -4. Okay, so it's useful to have your original coordinates. We are reflecting in the x-axis, which means which coordinate stays the same? X, and which one changes? Y. So we could, without regraphing these, list out A prime, G prime, I prime, and give our new coordinates without ever graphing the new figure. So where would A prime end up?
4 +1.
4 +1. What about G prime?
4.
Careful.
5.
The x-axis means that the x-coordinate stays the same and the y-coordinate changes sign. So 4, 5. What about I prime? 1, 4. Questions, concerns about letter A? You don't have to graph the reflection unless it says graph the reflection and find the new coordinates. If the directions just say find the new coordinates, you can graph it if it helps you, but it's not a requirement. All right, for letter B, what are these letters they're telling us here?
G, E, C.
G, E, and C. So let's start with point G. What are the coordinates there?
0, -2.
Okay, I think G is the one that's here, right? 0, -2. What about C?
5.
That's the one at 5, 0. And E? 3, -3. This time we're reflecting in the y-axis. I'm just going to take out some of my graph here that I'm not using. So G prime, if we're reflecting in the y-axis, which coordinate stays? The y. Reflect in the y-axis, the y-coordinate stays. The x-coordinate is going to change signs. But if we change the sign on 0, what is it?
0.
Still 0. And that should make sense to us, that if the point is on our line of reflection, it's not moving. So the coordinates didn't change. C prime. What are my new coordinates? I'm going to C. Is C off to the side? -5, 0. Good. And then E prime. -3, -3. Good. Questions, concerns about reflections? Warm, fuzzy feelings. Cold, prickly feelings. Void of all emotion forever. Okay?